Hello everyone and welcome. I'm Hugh from LOXONE and this is part of an ongoing series of focus videos looking really in depth at specific things to do with LOXONE and what you can do with them. So for today, I've got a particular idea in mind of something that happens to me quite regularly and is also very, very scalable no matter the size of the problem that you have with it. And so what I'm talking about specifically is networking devices and whether they're online or not. So to give you an example, this might be in a comms room, a server, and you want to know whether that server's online or not, and if it's not online, you want to do something about it. Or my particular scenario, in my own house, I have a router that's been provided to me by my broadband provider because I haven't gone out and bought myself an aftermarket router. And like many broadband provided routers, not to mention any names, they do have a habit of dropping out every now and again and losing connection to the internet. So I want a way to be able to check whether my router is still connected to the internet, and if it isn't, I want to reboot it. So how can I do that with LOXONE? Well, there is one very, very simple block that I can use that kind of does everything I need to in this scenario, and that is ping. So ping is a general network term for sending a packet of data to an IP address and seeing if you get a response. So we have a ping function block within LOXONE that we can use in LOXONE config that as long as our mini server is connected to the network, it can start pinging for an address somewhere. In my example, I'm going to use Google's public DNS service, because that means if my mini server all of a sudden stops being able to ping Google's DNS, it means more than likely that my router is disconnected from the internet. And then what I can do is when it does do that, I can then reset the router. So if we move over to config to show this, here we go. So here I have just an ordinary blank config file. I'm already connected to this mini server here. And so I can just get straight away cracking and getting into it. So if this was a router in my house, more than likely what I would want to use to control it is a smart socket, because then I could just plug the router straight into the smart socket and the smart socket has a programmable relay on it. So that relay on my smart socket is going to be where my router is plugged in. So I'm going to pull that relay out. I'm also just going to create myself a relay on the mini server as well, just because sometimes it's nice to see a pretty light light up. And I'm going to pull that out as well. So bear in mind, in your real scenario, you'd only have one relay. I'm just doing it to show you the difference between a smart socket and by using a relay on the mini server. And then, as I said, the function block that we're going to need is called ping. So you can see we have a function block there for ping. And the way this block works is fairly straightforward. As you can see at the moment, it's red, and it's red because we haven't completely configured it yet. And the thing we really need to configure is the address that we want to ping. Now, this could be any address. This could be our router itself. This could be a NAS drive. This could be a server on our network. As long as that device allows ping requests, I think in Windows Firewall, it's called an ICMP request, then we can use it with this function block. Now, in my example, I want to see and check and make sure that my router is connected to the internet. So I want to ping an external address. And probably the best one for me to use is 8.8.8.8, and that is Google's public DNS. And as you can see, as soon as I've typed that in, the block goes green because it's now ready to use. The other things we can do within the ping function block is we can say a delay. And so that means that when the mini server restarts, how long after the mini server has finished restarting before this block becomes operational again. Now that makes a lot of sense because of course, if the mini server is rebooting, it may take a while for all of the various services and operating system on the mini server to become fully responsive. So we want to make sure that it has that in operation and also that it's correctly connected to the network before it starts pinging. Because of course, if it was a whole site-wide power cut, then our mini server might actually reboot before the router. So we don't want it to start pinging the router or pinging a device on the network before we've given the router a chance to restart. So I'm going to leave that at 10 seconds. We can also specify the ping interval. So this is the duration between successful pings. So if this block sends a ping request and it gets a successful response, how long does it wait before it tries again? We can also specify a timeout duration. So this is when there is an unsuccessful ping, how long it waits before it tries again. And then finally, how many unsuccessful pings in sequence before it triggers the output to change. Okay, great. You can see that you can also use those parameters there as inputs as well. And then the other input you have is DIS, disable. And you have that because by default, the ping block just starts pinging straight away. But if you wanted some logic whereby something had to happen first before it started pinging, you would imply that into DIS. And then on the output, you have a single output, which is online. So for as long as the device that you're trying to ping is pingable, this output is on. And when that device is no longer pingable, that output goes off. Okay, great. So now that I've shown that, before I start getting into the next bit of logic, let me save that in. And then when I've saved that in, I will start live view. So just give it another second to reboot. And here we go. Start live view, and you can see that that output is on, and that is because my mini server here is connected to the network, so it can ping 8.8.8.8. Now, of course, I could disconnect the network lead on there, but then I'd also lose connection to live view as well, so I wouldn't be able to show you it changing status to off. But what I want to do specifically in my scenario is I want it that when this does go off, I want it to turn my router off and then turn my router back on again. Now, there are several ways that I can do this. Firstly, I probably need to have some logic that keeps this relay on, just generally speaking. And that, more than likely, would be a switch block. You'll see me use in a lot of the videos a switch blocks because it's just a great all-rounder. So that relay would go onto that switch block there. Now, I can't set on a switch block that the default status for a relay is on. I have to turn that relay on first, or turn this switch on first before it can do that. But what I can do is turn on remnants. And that means that if the mini server reboots, that relay will go back to whatever state it was before. So that is what I'm going to do, and I'm going to save that in. And then when I've saved that in, I'm going to go onto the web interface. I will just pull over to my other screen so you can see it as well. And here we go. And then when that loads, give it another second. I'll tell you what, while that is loading, I'll continue with the next bit. So what I'm going to do when that web page loads is I am going to turn this switch block on because that's what I want its default status to be. But then what I want is when this goes off, I want to turn this switch block on, turn this switch block off, and then after maybe 10 seconds, turn this switch block back on again. So what I need first and foremost is I need to recognize the off from here. But I actually need the off to be the on and the on to be the off, if that makes sense. I need to reverse the way around this works. And so to do that, I have two ways. I can either hover over it until the little black dot appears and I can click so it goes red, or I can use a function block called not, which inverts the value. So I can take the online there into not. And so what this means is this output here on the not block will now go on when this is off. Okay, and I'm going to rename that as ping as well, just so I know that that's what it's for. Okay, so this will now go on when this goes off. The next bit I want is I probably want to only recognize when it's the rising edge of this going on. So I only want to send a pulse to this switch block. And so to do that, I would use an edge detection function block. And as you've seen, probably every video if you've been watching them, I use edge detection a lot because it's really, really useful to only get a pulse on an edge of an output or input changing. Okay, great. So I can now take the rising edge and I can say that that turns that switch block off. So now when it stops pinging, when the ping goes offline, this will go on, which will send a pulse to turn this switch off. Wonderful. What I now need is to turn this switch block back on again a few seconds later. Again, several ways I could do this. I could, for instance, use a retractive switch, which has a selectable output duration. There are various other switch blocks I could use. I could even do it from a memory flag and change the delay on the cycles, or I could just use the most simplest block to do it, which is a delayed pulse. So I could take that same rising edge into my delayed pulse, and I could delay it by 10 seconds to then send a half-second pulse, and then that would turn that switch block back on. Now, the reason that I've done all of this logic like this is because if I didn't have this edge detection here, what would very, very likely happen is I could actually end up just constantly having this switch off, which means that I could never turn it back on. And I also want to make sure that I've created some logic whereby it truly is only at the start of this ping block going offline that it turns this switch off, because what's going to happen otherwise is I'm going to be in a logic loop where the switch block is going on, off, on, off, on, off. So by doing it this way with edge detection, I'm only sending a single off, and then after that 10-second time, it's going to turn this switch block back on, which is going to reboot the router, but it's only going to do it the once. So it's not going to keep turning that switch off as soon as it's restarted and then turning it back off and then back on, back off. It's only going to turn it off the once. And it would then have to go through a complete cycle of 8.8.8.8 being pingable again and then not pingable. Now, this is desirable because, of course, if it reboots the router once and that didn't solve it, then the problem isn't the router. And so all of this should mean that when I'm in the app and I'm in here, I can turn that switch on, and you heard the relay click, and I'll just change my camera over as well. There we go. So you can see that that is on. So my router is currently on. And if I'm in live view, you can see that currently 8.8.8.8 is pingable. This is brilliant. This means that everything is working exactly as it should. So let's just to show you it working, because as I said, I can't disconnect my mini server from the internet because then I will lose connection to it as well. But let's change the address that it's trying to ping to 8.8.7 instead. Just an address that I hope isn't real and isn't there. And if I then save this in instead, we can see almost immediately that that stopped being able to be pinged, and so it turned the relay off. And then there we go. You can see that that address cannot be pinged, which means that our switch block is currently off. Now, what also happened is it didn't send the rising edge pulse because the mini server hadn't quite finished rebooting yet. So I could add in an extra little bit of logic that I actually delay this as well. So I could add in another delay to here. So I could actually do the same not block into here, but then this not block, instead of going into the edge detection, I could actually stick it into a block called switch on delay instead. And then I could actually make that delay, let's say 10 seconds as well. And the reason that I would do that is because the switch on delay will only turn the output on if the trigger has been held for the period of time that you specified here. So that makes sure that if on a reboot of the mini server, this goes straight to off, it wouldn't do what we've just seen here. And then if I just save that in again, and then as soon as that's finished saving in, I will go into live view. You can see here that you have to have that 10-second period on a switch on delay, which has happened because, as you saw, and there we go, and now my relay has restarted because it got to finish that whole cycle. So there we go. That is the ping block. So the ping block you can use to ping an address, and this output will go on or off depending on whether it's pingable or not. And then using some additional logic, we can dictate what happens as a result. So in my logic here, I've got it that if this goes off, this not block turns on. And if that not block is on for a period of 10 seconds, it turns this output on, which goes into an edge detection, which on the rising edge will turn this switch block off. And then 10 seconds after that rising edge will turn the switch block back on again. So a router reboot in the case of loss of internet. And we could use this, as I said, for anything that we can ping. I could use it for the router itself. So rather than having to look for an external address, I could look to see whether the router's online. It could be for a server, just about anything I want. Excellent. If I now stop that live view, I hope you've enjoyed, and please join me again next time. Thank you very much, and goodbye.